What we have here is, what is this? Push the button. Oh, first turn on the power, push the button. Okay, push the button. LED light, push the button. LED on, push the button. LED bot on, push the first button. LED on, push the second button. LED on, push the button. LED on. So this is an OR gate. Let's see the circuit. I'm using two transistors here and two input pilot lamp, and the output is this. See? Button 2, the button. It's an OR gate. Let me see the table of the OR gate here. Oh, wow. So let us see the circuit. So we have here the circuit of an OR gate. Two transistor. A transistor I use is 2N222A. Transistor 1, transistor 2, push button 1, push button 2. And then we have the supply here, 12 volts. Then we have the pilot lamp here, input signal, input lamp, LED. And then this one, input 2 from the switch button 2. And then we have this resistor. They call it pull down resistor according to the Pulse Prophets in YouTube. And this one, this is the output, the LED. First, in order to, I don't know how to, what is the value of each resistor, so I decided to compute using Kirchhoff's voltage loop and Ohm's law, finding the resistor here in series with diode, simple as Kirchhoff's voltage loop here, voltage supply goes here and back to the negative. Finding the R6, Kirchhoff's voltage loop here and here. Finding the R5, Kirchhoff's here and here. And then we know the value of the voltage of the LED and also the current, forward current of the LED. We can calculate now the R5 and the resistor here and the resistor here. These two and these two, the base resistor. This is computed already. This one, I'm using the common sense. If we have a voltage drop here, from here to turn on the transistor, must be equal to the voltage here. And I computed the current at I base here using the data sheet of this transistor. IC is equal to HFE times IB. We got the current here, and then the voltage here we get here by subtracting by assuming that the voltage across R4 is equal to this voltage of the base minus the voltage of the base emitter in saturation is equal to this voltage R4. And I've got the voltage here and the current here from the data sheet transistor. And now we got the R1 here. Same here. I've got the value using the transistor data sheet here. When the current flows here, I'm assuming that the current we need to flow here to saturate is 25 milliampere. That is the current of the data sheet of this LED. 25 milliampere forward voltage. So we need 25 milliampere flowing here using the data sheet of this transistor, the characteristics, the HFP, and we got the IB and the IC. Also in here, this one. So we got the value of the base resistor here using that formula. So many computation here. But when you push the button, the LED lighted. This input LED and output LED. Push the next button, LED here lighted, LED here lighted. Push both the button, LED both lighted. That is the operation of an OR gate. If there's each or any one of the button will press, there's an input. Signal 1 input equals signal 1 output. 1 input equals 1 output. Simple as that. So hard to compute the resistor value. This one also. See the computation. Okay, let's do. Push the button, release, push what the button, and this is an OR gate. I think we can, let's see if we can do it in actual circuit. Let's build the circuit.